Bienvenidos, indeed, and welcome Anne Arundel Community College learners from the CTS-130 Section 402 course for the spring 2021 semester. In this Cisco Networking Academy ITNv7 activity, we're going to be taking a look at a hybrid activity that was created by faculty at AACC. And so this is skills activity number 4, where you're going to be working with SSH and securing network devices. So let's dive in and take a look at the activity. Here is the overall topology that we're going to be working with. Again, a PC, a laptop, a switch, a router, and then the remote PC. On the right-hand side, we have our addressing table, along with a series of steps that we're going to have to execute on here in order to correctly configure everything and reach all 80 points for completion. So let's go ahead and get started here. And again, it's talking about configuring the router and the switch based on the requirements. And so it looks like we will not be configuring any of the PCs. Those are probably good to go. So let's log on to router A. And you can see the interfaces are up for gig 000 and 001. We're going to go from user exec to privilege exec, and then from privilege exec with the configure terminal command, we're going to go into global config. Now, we're going to prevent iOS from attempting to resolve mistyped commands to a domain name. And we know that this is no IP domain dash lookup. And so we pick up 2 points right there for that. The host name matching the value in the addressing table. And so we're going to go ahead and set the host name to RTR-A, right? A little bit different from R1 or router A. So RTR-A, and we pick up a few points there. We're going to require that newly created passwords be at least 10 characters in length. Well, that sounds like it might be a security password issue, right, where a minimum length of up to 16 characters can be used, but we're going to go with 10. And again, we pick up a few points there as well. So a strong 10-character password for the console line. So let's get into line con 0. Whoops. And let's throw a logging synchronous in here, right, just for good measure. And then let's set the password here on the console line to @C, capital C-O-N-S 1234 exclamation mark. And we should get some points there, and we do. Let's hope we don't ever have to use that when logging in. And then we're going to put the login command here, and let's see if they give you some points for that. They do. There is a point for that, because remember, that command on the console line, do show run pipe to section line con 0. That login command is not there by default. So we need to put it in there. And when you have it just here on the console line, it's going to use the password on the console line. If we had login local, then it would look to the local user database, a user created by you saying username, the user's name, maybe a privilege level, and then a secret or a type 7 password could be used. All right. So the console line looks good. Ensure that the console session closes after 7 minutes exactly. And so we know that that is our exec timeout 7. And so we pick up another point there as well. So encrypted password for the privilege exec mode. Well, let's get out of the line configuration mode back into global config, where we would say enable secret, because we want it to be encrypted, right? So enable secret, and we're going to use 9 capital E XEC exclamation mark 1. Wait. Yeah, exclamation mark 1, 2, 3, 4 @ And let's double check this, and I'm hoping that we never have to type this in again. 9 EXEC exclamation mark 1, 2, 3, 4 @ And so we should get a point or two. We pick up 2 points there. And a message of the day, right? So how about a banner MOTD? And what are we going to say? Warns about unauthorized access to the devices. So no unauthorized access is allowed. Log off now. And so I'm going to put that in quotes, but we're going to do the delimiting characters. I'm going to use the $ signs here. And we'll see what happens with this. Do we get any points? And we do. All right. Password encryption for all passwords. In other words, we need a service for password encryption. All right, so now it says here, impede brute force login attempts by using a command that blocks login attempts for 45 seconds if someone fails 3 times within 100 seconds. So if I say login, we're going to block for, and let me reread this again here. Brute force login that blocks login for 45 seconds. If they have 3 attempts within 100 seconds. And so clearly challenging you here to mix the values up that we typically saw, which were, either 2 minutes, 3 minutes, and 4 attempts. And so let's see if we go from 16 to 20. So that was 4 points right there. So a good pickup there. And a username. So now we're going to create a local username. And the username is going to be all caps Cisco and then all lowercase admin all together with an encrypted password, right? That type 5 password of 9@55W*RT !@. Let's double check this. And that looks good. And we should see whether we get points or not right there. So now we're going to enable SSH. Now, my question to you is, are we ready to enable SSH, or are there some things we need to do? Now, this says enable version 2 first as the first thing to do. However, we haven't enabled SSH yet, right? And we haven't even generated the crypto key, and we certainly haven't set the domain name. So the first order of business is going to be our domain name. We're going to say IP domain name. Remember, this is used as part of the key name, along with the host name of the router. And so IP domain name, Cisco CCNA, CCNA.com. And we picked up 2 points there. So good to go. Now we're ready to say crypto key generate RSA, and it wants a key of 1,024 bits in length. Now is when I would say IP SSH version 2. Remember, version 199 is only on Cisco devices for backward compatibility with legacy gear. And a lot of that gear should probably be gone. At some point, SSH 2.0 would be the default, but always good to have SSH version 2 because 199 is highly exploitable. All right, so we've taken care of all of the SSH configuration here, and now it wants us to do some Vty line work. So let's say do show run section line Vty. As you can see, we've got 5 Vty lines 0 through 4. So line Vty 0 through 4. And I'm going to go ahead and say logging synchronous here as well for good measure. And they should use SSH. So transport input should be SSH. And we're going to pick up a few points there. The Vty line should use the username and password that were configured to authenticate logins. The login local, right? So the local user database. You can see where it had transport input none, meaning no one can connect remotely with any protocol, and no login, meaning that no one can get logged in. And the exec timeout was 00, meaning you'd be logged out immediately anyway. Right? So we've got this login local, and then finally, we're going to do our exec timeout here for the same value that we used on the console port, exec timeout 7. All right. So let's go ahead. Let's save our config here. We don't want to lose any of that work. And interestingly enough, here we're at 32 points. And the only thing we have left to do is the switch, and there are far fewer commands here. So let's find out if the switch is going to be a little kinder with the allocation of points to get us to that 80%, or the 80 out of 80. All right, so let's get into global config. Let's do our host name, right? We should be able to do this in our sleep at this point. Switch-1, or SW-1. And after the host name, all unused switch ports are administratively down. And what that's really saying is all unused switch ports should be administratively shut down. So how do we see that? Well, do show IP interface brief. And you can see that a lot of the unused ports are, well, I should say all of the unused ports are down. None of them are administratively down. So which ports are being used? Well, Fast Ethernet 02, 10, and Gig 01. So 2, 10, and Gig 01. So we're going to go interface range, Fast Ethernet 01, comma, Fast Ethernet 03, all the way to 9, and then Fast Ethernet 011 to 24, comma, Gigabit Ethernet 0, we're using 01, 02. We're going to make sure we get this right. And so now I'm simultaneously in all of those interfaces at one time, where I can simply say, shutdown. And boy, yeah, that bumped us to 57 out of 80, right? So we got everything there. And how would we check to make sure that we did the job correctly here? Show IP interface brief. And there we go. Any port not up has been administratively shut down. All right. So we're going to configure switch 1 to use a switch virtual interface on VLAN 1, use the information shown in the addressing table. And we can still see that, right? So let's get into interface VLAN 1. We want to make sure we say no shut. That was a 2-point command right there to bring that interface up. And what is the IP address we're using for the SVI for VLAN 1? Well, it's 192.168.1.254. And let's make sure we've got that right. 192.168.102. Yep. All right. And we're using a /24, 255.255.255.0. And we picked up 3 points there. Now we're only 18 points away here. So configure the switch so that it's reachable from remote networks, right? What command do we need to be able to reach the switch from remote networks? Well, that is our trusty IP default gateway command. And here we're 192.168.1.1. Remember, that default gateway is for traffic generated by the switch. If you're on the switch and you're doing a ping command or a telnet command or SSHing somewhere or trace routing somewhere, you are generating traffic from the switch. That is different and completely mutually exclusive from transit traffic, which is passing through the switch. Transit traffic would be traffic that comes from the laptop trying to get to the remote PC. It transits through the switch. It is not traffic generated by the switch. Transit traffic is PC traffic trying to get up to the remote PC, because the PC traffic is transiting through the switch to get to the remote PC. It is not traffic being generated by the switch. And that is the difference. And this is why we need that IP default gateway command on the switch, because if someone's trying to ping the switch from a remote network, the switch has to know where or whom to send the ICMP echo replies to if they're going to a network to which the switch is not connected and doesn't know about. All right, so IP default gateway 192.168.1.1, and that was a 4-pointer. We are now just 14 points away. So we're going to encrypted password for privilege exec. So let's go ahead and say enable secret. And again, it's going to be a crazy 9EXEC bang 1234 @ 9EXEC bang 1234 @ and we should see some points there. All right, so 2-pointer. And then a username of Cisco, so CISCO with an encrypted password, so secret of 9@55W *RD bang @. Let's double check this, 9@55W, because I can see losing points here very quickly. All right, so that takes us to 70 points. We're only 10 points away from being done here. Let's see if we've got it on the first go. So configure SSH as was done for the router. And I think this is where we're going to end up with quite a few points here. So let's set our domain name properly here to Cisco CCNA.com. We should pick up a few points there. We do. And we're going to go ahead and say crypto key generate RSA. Whoops, RSA. It's going to be 1024 bits in length. We pick up a few points there. And then IP SSH version 2 is going to give me a point. We're now 5 points away. So SSH has been configured just like we did for the router. And now configure the Vty lines just like we did for the router. But remember, on switches, do show run. And we pipe that to section line Vty. You'll see that there are 16 Vty lines, 0 through 15. And here again, these have been locked down with no login, transport input, none. And we need to get in here and sort this out. So let's go ahead and say line Vty 0 to 15 so that we're in all 15 of the Vty lines. And we're going to do the same thing we did for the router. So we're going to say transport input SSH, and that gave us 2 points. We're only 3 points away here. And where are we at here? Sorry, I have to look back up at the router. They should use the username and password, so log in local. Right, we picked 2 points up there, only 1 point to go, and that is our exec timeout 7. And that should be 100%. And there is our 80 out of 80. Now, hosts on both LANs should be able to SSH to the switch management interface and the router A gig 00. And that's a typo. It says gig 00. Remember, on the router, and oh boy, this is going to be not fun here, at CONS 1234 bang, and then 9EXEC bang 1234 at, okay. So IP interface brief, you can see that the interface is actually gig 000, but you know what's happening here. It's the gig 00 interface, 000 interface that we're talking about. But let's come to the remote PC. And let's see, can we even SSH as the user Cisco admin to the switch's switched virtual interface, which is 192.168.1.254. And take a look at that. And so the user password for that is 9@55W*RD bang at. And we are on switch 1. Now let's test and see, can we get to the router? Let's go do that from the laptop here. And we'll say SSH -L Cisco admin. And we're going to the 192.168.1.1. There's my password prompt. And it's going to be 9@55W*RD bang at. And there is our MOTD as well as the prompt for user exec mode, not privilege exec, but user exec mode on router A. All right, well, that is going to do it for this sort of hybrid homegrown skills activity, skills number 4, where we took a look at doing some SSH work as well as securing the network devices. Again, all really, really good tasks that we need to make sure we have a mastery of as we get ready to move into SRWE v7. All right, guys, if you have any questions, let me know. Thanks so much for watching, and I hope to see you in the next video.